This is a very interesting method to analyze pictures, where they take various moon landing photos and they basically do what you see here. They compare the differences in movement to see how far away the landscape is in the background. Okay, it's stereoscopic method. As you can see here, you can see as you're moving back and forth between two perspectives, back here it doesn't move farther in the distance, and up close it moves more, obviously, right? So, and you can see sort of the movement patterns. This moves, but this doesn't move as much. You can see with the bushes there, and then we have here, you can see how the stacks don't move because they're so far away, right? And here's sort of the formula they're using to figure out how far away the object is. Okay? Knowing the distance to the front edge, 5 meters, and the front edge offset, 88 millimeters, can be measured by a ruler and 2 white grasses. Distances to the trees offset 0.2 millimeters to a close to 2 kilometers at the boundary of parallax occurrence. And this was done by a guy who has a PhD, in the Department of Physics and Technology, okay, in the Ukraine. And you can see he did it with numerous photos and he got the same result every time. This is pretty good information for proving that there was faked footage. Okay, so we have like 2 pictures here, for example, he's analyzing, and he's doing this parallax with. And you see how the background's moving? See that? Okay. Nearby objects, the LM, the rover, the astronaut Jim, are shifting relative to each other. The Apennines and the crater St. George are also moving as a whole. Moreover, the shadow is changing on the mountains and the crater. This finding indicates that it is less than 300 meters to the background. The mountains instead of 5 kilometers. Say they were claiming that it was 5 kilometers away. Therefore, with such a small alteration to the camera position in Dave's hand, several tenths of centimeters, the mountains should not move. They should remain static, 0 parallax, as we saw up here with the stacks. Say it should be like that. But instead it moves when you get down here. See how it's moving? It means it's only 300 meters away, which is like less than it's about 1,000 feet. Okay, in addition, the Apollo 15 stereoscopic photos feature a clear separation line between the mountains in the foreground based on the distance between the camera and the rover. The distance to the panorama of the lunar scape cannot be more than 150 meters. Conclusion: it is very probable that these images were taken on Earth in a studio stage. Okay, on the left, Dave collects samples. Mount Apennines are in the distance. Apennines are in the distance over 35 kilometers. The Apennines and the crater St. George are on the right at the distance of 5 to 8 kilometers. But we can see here rectangles highlight the areas selected for parallax examination. Okay, and you see here the movement. Despite a slight offset of the camera, the mountains are moving, which contradicts the condition of distant mountains. And we see here the subtraction of the front parts of the 2 images on the left. This is a very interesting method to analyze pictures. Okay, it's stereoscopic method. As you can see here, you can see as you're moving back and forth between 2 perspectives, back here it doesn't move farther in the distance, and up close it moves more, obviously, right? So what they do with this methodology is they take various photos and then they compare the differences in movement to see how far away the landscape is in the background.